Hey everyone, and welcome back to the channel. Ever wonder how computers, especially artificial intelligence or AI, make sense of a world that's, well, messy and unpredictable? How do they guess what might happen next? A big part of the secret lies in something called a probability distribution. Sounds fancy, but stick with me. Today, we're breaking it down in super simple terms and showing you why it's absolutely key for making AI smart. Let's dive in. Think about your day. Will it rain? Will your team win the big game? Will you actually enjoy that movie everyone's talking about? Our world is filled with maybes, right? It's full of uncertainty. Now imagine building a machine, an AI, that has to deal with all this uncertainty. It can't just freeze. It needs a tool to understand the chances of things happening. And that tool starts with probability. Okay, so to work with chances, we first need something called a random variable. It's just a fancy name for assigning a number to a random outcome. Like, how many heads did you get when flipping a coin 3 times? That could be 0, 1, 2, or 3. You can count the possibilities. That's called discrete. Or think about your height or the temperature. These can be measured and could technically be any value within a range. That's called continuous. Got it? Counting versus measuring. Simple. All right, now for the star of the show, the probability distribution. Imagine it like a map, but instead of showing land, it shows all the possible outcomes of our random variable, like all the possible results of rolling a die. And crucially, it tells us the chance or probability of each outcome happening. It shows how the total 100% chance is distributed or spread out among all the possibilities. Is one outcome super likely? Are they all equally likely? The distribution tells us, like you can see on this chart, probability distribution of a fair dice, all numbers equally possible. Now these distributions follow 2 very important common sense rules. Rule number 1, probabilities can never be negative. You can have a 0% chance, but you can't have a minus 20% chance of something happening, right? That makes no sense. Rule number 2, if you add up the probabilities of all possible outcomes, they must equal 1, or 100%. This just means something has to happen from the list of possibilities. These 2 rules keep everything logical. So how do we actually see these distributions? Well, it depends if we're counting or measuring. For discrete things, like dice rolls, we use a PMF, or probability mass function. Think of it as a bar chart showing the exact probability for each specific outcome, like the chance of rolling exactly a 4. For continuous things, like height, we use a PDF, or probability density function. This is usually a smooth curve. It doesn't give you the probability of being exactly 175 centimeters tall. That's technically 0, but it tells you the likelihood of being within a certain range, like between 170 centimeters and 180 centimeters. Bar chart versus curve. There are lots of different shapes these distributions can take, depending on what we're looking at. You'll often hear about the Bernoulli distribution. That's just for a single event with 2 outcomes, like one coin flip, heads or tails. Then there's the binomial, which counts how many successes you get in a fixed number of tries, like how many heads you get if you flip a coin 10 times. And the most famous one is probably the normal distribution, that classic bell curve shape. Lots of things in nature, like people's heights or measurement errors, tend to follow this pattern. Okay, enough theory. Why should we actually care about these distributions? Well, they help us make sense of randomness. They let us make educated guesses or predictions about the future, not with certainty, but knowing the chances. They help us spot patterns hidden in data. And ultimately, they help us make smarter decisions when we're not 100% sure about the outcome. Now let's connect this directly to AI. Why is it so important? First off, AI rarely gets perfect information. Data can be noisy, incomplete, messy. Probability distributions allow an AI model to express its uncertainty. Instead of just saying it's a cat, it can say, I'm 70% sure it's a cat, 20% it might be a dog, and maybe a 10% chance it's just a fluffy rug. This ability to say, I don't know for sure, but here are the chances, is huge for making AI systems we can actually trust. You know all that cool AI that generates images from text, writes articles, or even makes music? That's generative AI. And guess what's at its heart? Probability distributions. These AI models learn the underlying distribution or pattern of the data they're trained on, like learning the essence of what makes a cat picture look like a cat picture. Then, they use that learned distribution to generate brand new examples that fit the same pattern. It's like learning the secret recipe. Distributions are also vital for standard AI tasks. When an AI classifies an email as spam or not spam, it's often calculating the probability it's spam. When it predicts house prices, it might give a range of likely values. That's using a distribution. And in language, predicting the next word in a sentence like your phone keyboard does, that's all about calculating the probability distribution of possible next words. Even the process of learning an AI often relies on distributions. Think about training an AI model. You show it lots of examples. How does it learn? Often, the goal is to adjust the AI's internal settings so that the data you showed it becomes as likely as possible according to the AI's model. It's trying to find the settings that best explain the distribution of the data it saw. Fancy terms like maximum likelihood estimation are all about this idea. Okay, let's wrap it up. Probability distributions are like maps of chance, telling us what could happen and how likely each possibility is. They are absolutely fundamental for dealing with the uncertainty of the real world. And for AI, they're not just useful, they are foundational. They let AI handle uncertainty, generate creative outputs, make predictions, understand language, and even learn from data in the first place. They are the language AI uses to talk about maybe. So that's the scoop on probability distributions. I really hope that made this important idea a bit clearer and less scary. If you have any questions at all, drop them in the comments below. I'll do my best to answer. And let me know what other AI topics you'd like to see broken down like this. If you found this helpful, please give it a thumbs up and definitely subscribe to Retured for more easy-to-understand AI explainers. Thanks so much for watching, and see you in the next video.